Hello, GCC chemistry students. We're going to finish up chapter 11 now. We're going to talk about some graphs called energy profiles. There are four things that are important to know about these energy profiles. One, the transition state. That again is in between the reactants and the products. It's where the reactant bonds are halfway broken and the new product bonds are forming, so half formed. So again, half bonds is very unstable. So this is a very high energy unstable species. It exists for less than a millisecond. Again, you can't stop here. Then we also have delta H. If you remember, the triangle symbol is delta. It means change. So change in heat energy. The change in the heat energy is going to be the product's heat energy minus the reactant's heat energy. So change in heat energy, delta H. Then we have two terms we've talked about before. I hope you remember them. Endothermic is when the reactants have heat going into them. So they have to have the energy go into them in order to turn into the products. So these are things you need to heat up in order to get them to react. So heat enters the reaction. So the reaction looks like reactants plus heat energy makes products. So heat is on the reactant side of the equation. And then exothermic is when the reaction proceeds and produces heat. Heat comes out of the reaction. It exits. Exotherm. Therm meaning heat, like thermal underwear. So exiting heat. Exotherm. It comes out of the reaction. So the reactants lose or release heat. Heat is produced. Heat exits the reaction. So the reaction looks like reactants make products plus heat energy. So the heat energy is on the product side. So again, into heat, endotherm, exoheat, exotherm, exiting heat. Yeah. So let's look at some of these profiles. So here's the first one. This is for exothermic. So look at the reactants and the products are down lower. So that means the heat exited the reaction and the products ended up lower than they started as. Now notice to get from reactants to products, we have to go over this mountain. And TS is transition state at the top. So we have to have enough energy to get up over that mountain to get to the products. Now if we start at reactants, we have enough energy to only go up a little bit of way. We won't make products, we'll just roll back down to the reactants. So we can roll up and back down. Roll up and back down. We have to have enough energy to get all the way up and over the hill to turn into products. So the height of the hill is the activation energy. You can see that on the graph, E sub A. The difference between reactants and products is delta H. Okay, so the difference from reactants to products is delta H. Now delta H went down, so is that positive or negative in numbers? That can be a positive or negative number for delta H. You're correct if you said negative because it went down. Reactants and it went down to the products. So it's a negative delta H, like minus 54 kilojoules or something like that. So negative heat energy change for exothermic. All right, so that is the energy profile or graph of an exothermic reaction. So I want you to pause this video in just a minute and draw the energy profile for what you think endothermic would look like. Label the transition state, the change in heat energy, where the reactants and products are relative to each other. Draw the little hill getting over there. Show me where that transition state is. Show me the activation energy. Okay, pause for a minute. I hope you paused. All right, so let's look at your drawing and look at my drawing and see how close you were. So here is the endothermic energy profile. Notice now the reactants are lower than the products. We have to have heat go into the reactants to raise them up to the product level. So endothermic, into heat. The heat enters the reaction. Reactants go up to products. So we have our transition state is still the high point of that mountain. And then our activation energy is the height of the hill. And then the difference between reactants and products is the change in heat energy. So everything else stays the same. The only difference is reactants are lower than products. Now this time the heat went up from reactants to products. So is the change in the heat energy positive or negative? Yes, if you said positive, it's a positive change this time. Very good. All right, so this is the energy profile for an endothermic reaction where heat goes into the reactants to raise them up to the product level. Now this is basically what an energy profile looks like with a catalyst. Remember the catalyst I told you makes a second reaction pathway with a lower activation energy to get to the products. So here we have an exothermic energy profile. You can see the normal path with a higher transition state, higher height of the hill, higher activation energy. And then the thicker line is with the catalyst. Notice it's lower. Okay, the activation energy is the height of that hill, and it's less than the normal profile or the normal pathway. So the catalyst gives us a second path. So we have two paths now to get to reactants, and we can get there faster. So that speeds up the reaction. And I believe that is it for chapter 11. Hope you enjoyed it. Hope you watch all the videos. Good luck.